welcome to your algebra recording for the week of October 3rd. Yep, October. Hard to believe that September is now behind us and we are already in October. We're also working in the week 8 folder as well. As always, please make sure you've got a math notebook out and you're ready to try practice problems along with me. Try warm-up problems in your math notebook. Take advantage of the opportunity that you have to click pause and try problems. Or maybe rewind to hear something again. Lots of opportunity to take good notes with the ability to click pause and rewind with this being a recording. So I would like for you to start with a warm-up question. This kind of goes back to what we started with in the beginning of the year of literal equations, where we solved an equation for a variable. And this week we will need to be able to know how to solve equations for y. So get them in the form of y equals whatever on the other side of the equation. And sometimes to get them in that form of y equal, we have to move some terms to the other side of the equation. And we're going to start with practicing that with the 2 warm-up questions. And in each of these warm-up questions, what the focus is solving for y in each of the equations below. So take a moment, click pause, and work through these in your math notebook. And when you're ready to check your work with mine, click play. All right, so for equation number 1, we want to solve for y. That means we want to get y all alone on one side of the equation and move all the other terms to the other side of the equation. So that means that we need to move this 3x to the right side of the equation, and then we will accomplish our task of solving for y. So how are we going to move this 3x to the right side of our equation? Right now it's being added, so we are going to do the opposite of adding, which is subtraction. And whatever we do to one side, we have to do to the other side of our equation. Now we're left with just y on the left side of our equation, and we've got 6 minus 3x on the right side of our equation. Those are not like terms, so we cannot combine them. So our final answer is right here. Y equals 6 minus 3x. Then we have solved for y. Let's take a look at the second problem where we are solving for y again. We've got this -6 or -6 that needs to be moved to the right side of the equation to accomplish solving for y. So since we have y minus 6, we are going to do the opposite, and we're going to add 6 to both sides. Then we've left with just y on the left side of the equation. We've got that -4x, and we're going to add to it 6. Those are not like terms, so we cannot add the 6 and the -4x. So we're going to leave it just like that, and that's our final answer. So again, we're just solving for y. We're not finding the value of y. We're just moving things around so that we get y all alone on one side of the equation and all the other terms on the other side. When you've got 2 different variables in an equation, like we have x and y, you can't solve for either one of them. You can't get like y equals 6 or x equals 4. But what we can do is rearrange our terms. And in this case, we are just rearranging so that we could, what we call, solve for y. And that allows us to enter in inputs and get outputs easier, like we did last week with our function rules of applying an x value and getting an input or an output value or our y value. So this week we're going to look at graphing functions. We're going to graph functions for limited domains. What does domain mean again? Remember, domain is our possible x values. So that is what the domain represents as our possible x values. So we're going to look at how we can graph functions for limited domains. Like if I say x equals 6, 8, and 10, we're only going to graph for the x values of 6, 8, and 10. And then we're also going to look at how we can graph functions for a domain of all real numbers, so all possible x values, and what would be all of our possible y values. And then we're going to end with looking at arithmetic sequences. So those are our two big concepts this week. So let's take a look. How do we graph solutions when we're given a domain? And again, domain are our possible x values. So when we're given possible x values, how can we graph our solutions, which would be the y values? Remember, our inputs and outputs, domain is always your input, range is your outputs or your possible y values. So you're going to see things like this week where it says graph each function. Well, we only have one. Graph, I should say, the function below. Graph the function from the given domain. Okay, so here is our function right here. 2x plus y equals 2. And we want to graph it for the domain of, here's our possible x values. The D represents our domain. So here the D represents our domain. And remember, our domain is our possible x values. So really what this is saying is find the outputs when you have x equals -2, x equals 0, x equals 2, and x equals 4. So how are we going to do this? Well, the first step is to solve for y, because it's going to make it a lot easier. We're given our possible x values. Remember, these are our possible x values. And we need to then plug in our x values to get our y value. Well, right now the equation is 2x plus y equals 2. It's really hard to figure out what our y value would be. But if we rearrange the equation by solving for y, that's going to make it a whole lot easier. So let's do that. Let's solve for y. I'm going to change colors here to make this a little easier to follow. So when I solve for y, I've got 2x plus y equals 2. So how do I solve for y? I need to get y all alone, so I need to move this 2x to the right side of the equation. I'm going to do that by subtracting 2x from both sides. And I get y equals -2x plus 2. So that is my function rule. And now it's going to be easier for us because we have what y equals. So when we plug in a value for x, it's going to tell us what y equals just right here. It's a lot easier to rearrange and solve for y to do it that way. So the next, step 2, is we're going to fill in this chart here. So we're going to put in our x values and find out what our corresponding y value would be, and then put it as an ordered pair so that we can graph it. Because remember, up here it said to graph it. That was the whole goal, is to graph it. All right, so our first, here's our domain up here. It says the first input is -2. So what would be the output? Well, y is going to equal, y equals -2 times -2. We plug in our input in for x, add 2. What do we get? -2 times -2 is 4, +4. +4 plus 2 is 6. So y would equal 6. So the ordered pair, when my input is -2, my output is 6. There's my domain, there's my range. Now we're going to do that again. Our next domain input is 0. So when we plug in 0 for x, we'll have -2 times 0 plus 2. -2 times 0, that's 0 plus 2 is 2. So when our input is 0, our output is going to be 2. We'll graph these in a moment. My next domain that I'm going to plug in is 2 for x. So we've got -2 times +2 plus 2. -2 times +2 is -4. -4 plus 2 is -2. So when my input value, oops, I forgot to put that in here. We did that for 2. When my input value is 2, my output value is -2. And last one we're going to do is when our x value is 4. So whenever we see an x, we're going to plug in 4, and then we evaluate with our rule. So see, I'm using the same equation up here. I'm just plugging in what the domain tells us, which x value to input. -2 times 4 is -8, plus 2 is -6. So for my input value of 4, I get an output value of -6. And now I'm just going to plot these points. So we only want solutions for this given domain. So these 4 domain values. So all I'm going to do is plot 4 points. I'm not going to connect them in any way because we don't want the outputs for any of the in-between points. We only want the outputs for these 4 domain, so for these 4 inputs and outputs. So the first coordinate pair here is -2, 6. So to plot a point, I start at my origin, I go to the left 2, and then up 6. So there's that first point, -2, 6. Plot my next point, which is at 0, 2. So I don't go left or right, and I go up 2. So that's that point 0, 2. Then I go to do this point, 2, -2. I'm going to go to the right 2 and down 2. And that would be this point right here. So I went 2, -2. My last point that I'm going to plot is 4. So I go to the right 4 and then down 6. 4, -6. So that's all I'm going to do. I'm not going to connect these. I'm not going to turn it into a line. It's simply these points because I'm only finding the solutions for these 4 domains that were given. So we're only plotting points. So there is my steps. First step, solve for y. Get your equation in y equals so that when you put in your input and substitute that input for x, we really quickly can solve and find out what our y is. Then we put our input and our output together in an ordered pair, and then we plotted all of them. I'm going to go on to the next slide, so if you need more time here, go ahead and click pause. So now we're going to do the same thing, but a little bit different. We're going to graph a function, but now we're going to do it for all real numbers. We're going to do it for all real numbers. We're not going to have a specific domain. So we're not going to have specific inputs. It's for all real numbers. So I'm going to do this. It says graph the equation y equals 2x minus 4 using a table. So my step 1 is already done. So here usually we want to solve for y. That's already done for us in this case. So that's done. So we're going to use our equation or a function rule of y equals 2x minus 4. And now, since we're not given a domain, a couple values for our inputs, what we're going to do is we're going to choose several x values. So we're going to choose several x values to plug in and to find our output values. So I always like to do some negative and some positive. So we'll do -2, -1, 0, 1. So you can do more if you want. So when my x value is -2, I plug it into this equation to find my y. So 2 times -2 minus 4. And what do I get? What's my output when I do that? 2 times -2 is -4. -4, take away another 4, we get 8. So my ordered pair, when the input was 2, my output was -8. Let's do it, -1. So I'm going to plug in -1 where I see x. Whoops, minus 4. What do we get? -2. 2 times -1, I got ahead of myself, is -2. Take away 4, we get -6. So when my input was -1, we got -6. How about when my input is 0? 2 times 0 is 0 minus 4 equals -4. So when my input value is 0, I get -4. And I'm seeing a pattern here. Let's plug in 1. 2 times 1 minus 4 equals -2. So when my input value is 1, my output value is -2. So now we're going to plot all these points. -2, 8. So we're -2, -8. So it would be down here. Then we'll do -1, -6. My next point is 0, -4. My next point is 1, and in this case, I'm going to actually now connect all my points in a line because remember, this says for all real numbers. So this, we need to show that for any value of x, what the corresponding y value might be, right? Because it says for all real numbers. In the slide before on the problem, we only plotted specific points because we were given a specific domain. But this is for all real numbers, so we're actually going to put in the line. We're going to draw in our line. And then what's pretty cool from our graph is we can see any, we can choose a point like 4. If x equals 4, my y value would equal 3. And you're going to learn how you can find points and solutions from a graph. It looks like if my y, so you're going to look at different points. I don't think I lined this up exactly perfectly, but that's what you're going to look at this week. All right, I'm going to go on to the next slide. So if you need more time, go ahead and click pause here. And then the last concept you're going to look at, we're going to switch gears and look at a certain type of sequence. So a sequence is a pattern, right, that we have when we have numbers. And a certain type of sequence is called an arithmetic sequence. So in order for a sequence to be an arithmetic sequence, there must be the same difference between numbers and a sequence. Kind of like a linear sequence when we talked about that a couple weeks ago. So the difference, the same difference. So what do I mean when I say difference between two numbers? So what I'm meaning is when we go to 1 to 3, how have we increased? By 2. And we go from 3 to 5, we increase by 2. When we go from 5 to 7, we increase by 2. When we go from 7 to 9, we increase by 2. So here, the difference between each number in our sequence is increasing by 2 each time. So this would be an example of an arithmetic sequence that has a difference of 2, of plus 2, right? So to find the difference, all you do is take the number and subtract the one before it, right? So you could take 5 minus 3 would give us 2. So take any term in our sequence and subtract from it the previous number, and that will get you the difference. So let's try that below. Here's an example. This is an arithmetic sequence. So let's find the difference. So to find the difference, I take one term, like 7, and subtract from it the term before, 7 minus 10, and I get -3. If I did that with 4 minus 7, I should get the same thing. 4 minus 7 equals -3. If I take 1 and subtract from it the term before, minus 4, I get -3. So the pattern is to go from each number to the next, I would subtract 3. So to go from 10 to 7, I subtract 3. From 7 to 4, I subtract 3. I think you see the pattern. 4 to 1, I subtract 3. So the difference here in this sequence would be -3. So these are both examples of arithmetic sequence because they have the same difference between each number in the sequence. So these are examples of arithmetic sequences. I'm going to go on to the next slide. So in order, again, to determine if a sequence is arithmetic, you need to determine the difference and make sure that the difference between each term is the same. So I want you to look at 1 and 2. Now would be a good time to click pause, and I want you to determine if the sequence is arithmetic in each of those examples or problems, and if so, determine what the difference is. So for number 1, so from let's choose a couple numbers from 0 to 3. It looks like we're increasing by 3. From 3 to 6, we're increasing by 3. From 6 to 9, we're increasing by 3. 9 to 12 and 12 to 13, we're increasing by 3. So yes, this is arithmetic, and the difference is by +3. Whoops, put in that positive 3 there, plus 3. What about the second one? From 2 to 4, it looks like we're adding 4, or sorry, 2 to 6, we're adding 4. 6 to 8, we're adding. So because the difference is not the same in the first two numbers, we know right away this is not a arithmetic sequence. Because in order to be an arithmetic sequence, we have to have the same difference between each of our terms. I'm going on to the next slide. So one of the things that you might have to do when you have identified that you have an arithmetic sequence is to find a certain term in the sequence. Let's say we wanted to find the 20th term in the sequence. Well, this is an arithmetic sequence. We're increasing by 3 each time, and I only have the first term, the second term, the third term, the fourth term, and the fifth term. I need to find the 20th term. So I could keep going and adding 3 each time and doing it till I get to my 20th term, but that could take a long time. So instead, we've got this cool, great formula that allows us to determine the nth term of a sequence. We can find the 100th term, the 1,000th term, the 18th term, the 16th term. So we're going to use this formula, but let's identify what these letters and things mean in the formula. So the A of n lets us know whatever term we're trying to find. So this lets us know the term that we're trying to find. A1 is going to be the first term in our sequence. So here, the first term would be 1. N is the term that we're trying to find. -1, and D is the difference. We already talked about the difference. The difference between each number in our sequence. So let's find the 20th term. Let's find the 20th term. Whoops, let's do that. So we want to find the 20th term, so n is going to be 20. So A20, the 20th term, is going to be equal to the first term. The first term is 1. Plus, we want to find the 20th term, so our n is going to be 20, minus 1 times the difference. Well, again, to go from 1 to 4, we went up by 3. From 4 to 7, we went up 3. So we went up 3 each time, so our difference is 3. Then we do the math. So the 20th term is going to be 20 minus 1 is 19. Then we're going to take 19 times 3. So we're going to do our orders of operation first. We multiply. So 19 times 3 is 57. Then we add that to 1 and we get 58. So that means that our 20th term is equal to 58. So make sure you copy down this formula and what each of the letters and variables represent. Whoops. Right here. Yikes. What each of those letters and represent in that formula. And you know that you can use this formula to find any term in an arithmetic sequence. I'm going to go on to the next slide now, so if you need more time, go ahead and click pause. We're going to wrap this up with the key phrase assignment. So let me throw up the key phrase question. So in this recording, we went over, one of the things we went over was arithmetic sequences and how we can use this formula below to find the whatever term in a sequence. So this is our formula, and in this formula, we talked about what all these letters represent and what all the variables represent. What does A sub 1 represent in this formula? What does it represent? So that's your question. As always, if you need any help or have any questions as you're working through this week's material, let me know. I'm here to help. Otherwise, have a fantastic rest of your week.